hello guys. I am going to help and show you guys how to complete this mock exam. So if you had any questions about it, hopefully this will answer all of them. I'm gonna try to adjust the angle so you guys can get a little bit better of a view. Okay. So over the course of this, you'll see me pull out several different sheets. That's just to help make this go faster. I did everything in advance, so hopefully it'll help. Okay, so first question. Which of the following is a statistic? So statistic refers to a sample, as you guys know. And they both start with an S, so that'll help you remember, hopefully. Sample, statistic. Sample, statistic. If it's not a sample, any number, a statistic is any number that describes a sample, parameter, or population characteristic. Describe a population. Now the cool thing about that is also the same thing. Any number that describes a population is a parameter or a population characteristic, and all three of these words start with P. These two are used interchangeably to describe a population, and statistic is used to describe a sample. So now we're just looking for any number here that would describe a sample. A population mean would definitely not describe a sample, right? X bar. So X bar is sample mean. So that could work, yeah. This is population standard deviation. We haven't talked about that yet, so but it describes a population, so no. Sigma just means sum, which doesn't refer to sample or population, not the answer. Sample sigma, it's made up, so no, that's not it, and it would be B. Okay, number 2. So we're gonna have to describe whether the observational or the experiment. I'm just going to go through them real fast and explain my thinking on each one. So this is an experiment because there's an independent variable or a variable that we're manipulating as the experimenter, and that variable is the different cities. Because we're manipulating which city we're going through, and that is an experimental condition, that is an IV, and this is an experiment. That's what makes it an experiment. The dependent variable based on the different cities, or the independent variable, is the diameter, the fatness. So based on whichever city we're in, or the independent variable is the dependent variable, or the fatness. The only number here that would represent the population would be a population characteristic or a parameter is this 2 pounds, because we're talking about the population, which would be all rats. Every other single number over here, the 22, 26, 17, 2.67, and 7.82, and 4, they all describe the sample or statistics. Okay? Yeah. So these two are N, small n. These two are mean or X bar, sample means. This and this are S, or sample standard deviation. And this would be mu, which you guys haven't talked about because it's mean, population mean. Yeah, so that's that. It's experimental. Is there anything else? Yeah, response variable would be the dependent variable. Experimental conditions is the IV, or the independent variable of the different cities. Okay, and the different treatments would be New York and Kentucky, because those are the different cities. Okay, number 3. Hopefully you guys can see. I'm gonna try to move it a little bit as we keep going so you guys can definitely see. So this is also an experiment. Hopefully this one's a little bit easier to tell, so hopefully you guys could be able to tell that. The independent variable or the response variable is the different methods he's using to motivate his workers, and the dependent variable is the level of motivation that they have. I'm not going to go through everything again. Just kind of know it's an experiment, and yeah, what the IVs and DVs are. Again, the independent variable is the method because that's what we're manipulating, what he's manipulating. And the dependent variable is the level of motivation, because that's what we're looking at. Okay, next example. So this one's actually an observational one, because she is not manipulating anything or anything like that. She is just seeing, watching. She's not changing anything. So there is no independent variable. There's only the dependent variable, which is length. This would be a statistic, because it just is. And this is a population characteristic, because it's describing the population. And I said this just is, but it's just because it's describing the sample, like we talked about in question number 1. It's n. And this is also big N, which describes the population. What is n? So this was a error on my part. It should have been small n. And the answer is sample size. This is a definitional question. You should just know what that means. Okay. 6 through 8. Okay. So hopefully you guys can still see. Not really. Okay. Sorry guys, I'm trying to adjust this so you guys can see, but you obviously have your own copy, so it's not a huge deal. Professor Rat. So here in this question, all we're trying to see is whether the anxiety medication is working, and we're trying to find if there's a confounding variable. So a student had pointed out to me that I should have been more specific here. When I wrote this question, I intended it to say that each of the rats were put in a identical stressful situation. So I was stressing the rats out in exactly the same ways every time. If I had not stressed them out in the same way every single time, that would have been a confounding variable. But since I was intending for the situation to be the same every single time, there was no confounding. But if you read it differently, and if you had read it as every situation was a different situation for every rat, then that could have been a confounding. So yeah, the next one, there is a confounding actually, and that confounding is seen over here. He had the extroverts run and recorded their time, and then he had the introverts run and recorded their time. Now that's not a super obvious confounding, but the confounding is there, and it lies in the fact that he had one group run and then the next. So he had the extroverts run first and then the introverts. So all that means is that the extroverts were running at a different time than the introverts. They were running exactly 2 hours after the introverts were running 2 hours after the extroverts. So let's say that the extroverts had run at 4 p.m. and the introverts had run at 6 p.m. That changes different characteristics like light. So the confounding variable here would be time of run. And because of that, let's say it was darker, and so the path was harder to run. It was more dangerous, and it took the introverts longer to run that path because of the time that they ran at. So that's the confounding. It was a little bit hidden there. And usually it'll be more obvious if it's a question, but it's good to, if you caught that, that's very good. This one, there's also confounding, and it is the women's shelter. That is the very obvious confounding, or the most obvious confounding in here. And the first confounding is gender, but there is also a very subtle confounding in here, which is socioeconomic class. So the first confounding of gender, because he found these people near the women's shelter, there's a higher likelihood that the people in his sample are women. Because of that, women may have different rates of stress or higher weights in regard to the stress. So that could definitely affect the experiment. That could definitely be considered a confounding variable. The second one, socioeconomic class. People of lower socioeconomic classes are typically more stressed and bigger, so that could definitely be a confounding variable, but it is more hidden. If you caught gender, that would be a good one to catch. Hopefully you caught them both, but if not, hopefully at least you caught gender. And if not, then hopefully you'll look out for it later on. Confounding, so in case you're not clear on what confounding means, in an experiment you want the independent variable to directly affect the dependent variable. And that makes sense because you want to be able to say that this causes this. So if there's another variable, a confounding variable that's impacting the dependent variable, then you cannot say the independent variable is causing the dependent variable. And you don't want confoundings because then you can't say that. So that's what a confounding is. It's any variable that could affect the dependent variable that's not the independent variable. Hopefully that makes sense. Okay, so this question, the answer is B, double-blind study. And that's because the administrator is Jonathan, and he can't see. So it doesn't matter about Timmy. Timmy doesn't matter in this situation. Jonathan doesn't know, which matters. That's one blind. And then the patient doesn't know, and that's a second blind. If it was a single blind study, only the patient wouldn't know, and Jonathan would know. But since it's a double blind, they both don't know. So it's just based on the administrator and the patient. Timmy doesn't matter. So it's not a single blind. It's a double blind. Okay. Next one. Can you guys still see? Okay, so I'm going to move it again. Okay. So this one, basically, you just need to know what discrete and continuous are. Discrete, continuous, discrete, continuous. And that's just because discrete is any isolated point on the number line 1, 2, 3, 4, and continuous is not. It's depending. So just be aware, this is again a definitional question that if you know the definitions you should be able to get it. So yeah, hopefully you got those. Just kind of study definitions if you're having trouble with those kind of questions. Okay. So next, now we're going here. This is another bad choice on my part. When I was making this test, I shouldn't have included stem and leaf plot because you shouldn't make a stem and leaf plot for this because then they'd all be on the same stem. A better example would be if I gave you numbers like 22, 37, 54, and ones with different stems, because then you'd have like 2, 3, 5, and you could put the numbers over here. But since they're all on the same kind of 10 number, they would all fall on the same row, which would be bad. You do not have to do that, so don't worry about that. Okay, so next, what else do you have to do for this question? You have to make a histogram. So I already made a histogram. I'm just going to show you for the sake of time. So I made a very, very simple histogram. Right here you can see my histogram. It is just composed of 2 bins, 1 to 5, with 12 in this bin, and this one, which had 2, 6, 7 in it. Okay, so all you have to basically know is how to make a histogram. Label your, axes. I didn't do it here, but you should definitely do it and give it a title. So just know how to make a histogram. That's basically the whole thing of this question. It's pretty simple. Boys should be touching. You should have labels and all that kind of stuff, okay? Super, super, super easy. Okay, relative frequency trait. I also made one on this sheet of paper right here. For the sake of time, it's really not hard. If I was doing each number as its own category, you could do that. If you're supposed to make categories, maybe you could do like 1 through 5 and then 6 through 10. There's no 10, but you know what I mean. And so you just give the frequency of each number. So 1 would be the 2 under 1. There are 2 ones, 1, 2. 5 twos. So if you count the number of 5s in this data set, if you count the number of 2s in this data set, there are 5 of them. Same thing, there's 1 3. There are 4. There are 3 4s. There's 1 5. There's 2 6s, 1 7, 2 8s, and 2 9s. And then relative frequency is super easy. I just did in fractional form here. You should probably convert it out to a decimal. I just did 1 here. The rest are in the answer key, so you know what they are. It's 0.053, and that you got that because there's, when you add up all the frequency, which gives you n, you should know that. When you add up all the frequency, that gives you n. So n is 19. So to get the relative frequency, all you have to do is take 2 and you divide it by 19. And that's the relative frequency for this row, for 1. And that just means that out of 19 possible choices, there are 2 1s. And so the decimal for that would be 0.1053. Super, super simple. Yeah, that shouldn't be a big concern for you guys because you should know how to do that pretty easily. Mean, median, and mode also should be pretty easy. But if you do have concern about that, that's probably a pretty simple thing that you should know. But if you don't, I kind of have a little thing to show you. So you just kind of put them in order. You have to, for the mean, you add them all up. If you add all the numbers in the data set up, you should get 85. Then you divide 85 by 19, and you should get a mean of like 4.473. Yeah, median. There are 19 numbers in the data set, which we know based on when we added all those frequencies up, we got 19. So if you divide 19 is odd. So you take 19 minus 1 is 18. 18 divided by 2 is 9. So there are 9 numbers on this side, 9 numbers on this side, 1 in the middle, and 4 is that number. So the median is just the number in the middle. So it'd be 4 in this case. Mode is the number where there's the most of that number in the data set. And like we just saw in the frequency distribution, that number, the 5 of the 2s, so 2 is the mode. Hopefully you guys know how to do that. It's really, really simple. There are like 1,000 tutorials online, I'm sure. So I hope that's not an issue for you guys. Pretty simple. Okay, number 17. Draw an appropriate graph to represent this. So this question was really simple again, but it was just there so you guys could practice knowing like what kind of graphs to draw and such, that kind of stuff. You could have done a pie chart. I did a bar graph, and it's really simple. Again, you should definitely label all your axes. I didn't do that for this, but this would probably just be like frequency or a number of marbles, and then give it a title, and red, blue, purple. So I just did a bar graph. It's really simple. You guys should know how to do that already. Again, there are a lot of tutorials if you're a little bit hazy on it and you need to like figure it out. This question was mostly just to test, to make sure that you knew to determine which was the appropriate graph for like categorical data like this, and also know how to draw it. So that's pretty simple, shouldn't cause you big issues. So this is the one that I anticipate gave you the most trouble because it's the newest to you guys probably. So first, just definitional stuff. We need to know which one is which, right? So first, independent variable and dependent variable. So we know it's saying that books read and comedic skill are directly related. So the number of books you read directly impacts your funniness. So this is your X variable or your independent variable. And this is your Y variable or your dependent variable. So your funniness depends on the number of books you read, basically is what the claim here is. And then next definitional kind of thing, you need to know Pearson correlation is R. You need to know that correlation coefficient is R squared. You need to know how to determine the relationship of the variables. If you don't know how to interpret R squared and R, you can easily just draw a little graph of them. It should look a little bit like something like maybe like this a little bit, something like that. You know, you get the kind of idea. And so basically the answer to 20 would just be positive. because you can kind of see that this is going in a positive direction. And so that's positive, and it looks pretty strong the way I drew it, and it is pretty strong because the dots are close. There's less squared area, which means the dots are closer to this line, the closest to the line, except this one has a lot of squared area. But overall, this line has not a lot of square area, so that means there's a strong relationship. Okay, calculating this. This is like challenging because you guys are new at it. All you need to do is practice it until you can do it super quick. I don't expect it to be super quick at first, but try to get to a point where it's super quick. So again, for the sake of time, I did do it for you guys and I did it out. But I will go through each step with you guys so it is not challenging for you guys. So the first step that we need to do is calculate. First we need to write down the formula. You guys will have the formula with you. I suggest you write it down and go step by step again, just to make things easier. So we're trying to find R, right? Let's see, what's the first question that I asked you? Pearson correlation, yeah. So we're trying to find R. So R, the formula for this, I put it right here, is the sum of the z of x times z of y over n minus 1. Pretty simple formula. To solve this formula, we need to find the formula for the z squared, which I wrote right here, but I'll write it again. Okay. So, to break down this formula, the first thing we need is the x bar and the y bar. And then we need the sample standard deviation of x and the sample standard deviation of y. Okay? That's pretty easy. You should know how to do that by now. If you don't, you can just calculate it out super easily. All you have to do to get the mean is what we talked about before. You just need to plug them into the calculator real quick. And then divide by the number. And like this is 3.8. So you can see that right here. I should have wrote it out here, but 3.8. Y bar would be 5. The S is 1.92. 3.87. I can go ahead and do one of these with you. But that's something that you should probably know by now. So I don't want to focus too much time on that because there's a lot more to get through. So to calculate the sample standard deviation, as you guys clearly know by this point, we need to calculate the sample variance first. And so first step for that is what I like to always do is just write down the formula. And I really suggest you guys write down the formula even though you have the formula sheet, because it keeps everything nice and clean. And when you're taking a test like this, you really need to have every one of your variables laid out nicely for you. I know this is pretty clean, but it's not the cleanest that it could be. Label all your steps if you can. It just makes everything so much simpler for you. And it just keeps everything nice and clean, and that makes everything a lot easier. So the formula for sample variance is 1 over n minus 1. I know that's messy, but sorry. Sum of n I equals to 1 over xi minus x bar squared. And that's equal to the sample variance. And then to get what we need, which is S, or the sample standard deviation, we just take the square root of that. So S is equal to 1 over n minus 1, sum of n I squared, and then we just take the square root of that. Now it looks complicated, but as you guys have probably figured out by now, it's really simple. And all we have to do, let me just do the x for example. Super easy. all we have to kind of do is take each number. So we have x of I, so that's the first x. So 1 minus the mean, which we already calculated out to be 3.8. Then we have that now. All we have to do to that is square it, 7.84. So we have a first number here, which is 7.84. Okay? Really easy, right? Then we take the next one, 4 minus 3.8, square that, and we have a second number. Super easy. Plus 6 minus 3.8, square that, 4.84, fourth number, 3 minus that's all our numbers, and then we just add them up. And I see a lot of students for some reason get tripped up over order of operations. Just remember PEMDAS and you should be fine. So we have 14.84 right now. And then all we have to do according to this formula is just multiply it by 1 over n. So we divide it by 1 over n. But that's just, don't confuse yourself with that. So 5 minus 1 is just 4. So we just divide by 4 or multiply by 1 over 4. And we should get 3.7. So clearly when I calculated this is a sample variance, and then we just need to calculate the sample standard deviation, and it's the same thing, 1.92. And so if you wanted to, this confuses me, but if it doesn't confuse you, go for it. You can just write that out as a sample variance. But we have the sample standard deviation. So now you know how to calculate sample variance. As you can see, we got, hopefully you guys can see that, I don't know, 1.92. You can always go out by the 3.5. Okay, so it was easy to calculate that. You guys should know how to calculate that, hopefully by this point. If you don't, just practice, and you should get it soon, because it's not super hard. Okay, cool. So now we have the sample standard deviation. I'm just going to cross this out. And now we need to calculate the z-scores of everything, right? So I went ahead and did that for you guys over here. So if you need to check your z-scores versus mine, this is what I got. For the z-score part. Okay, so how you did this part was also pretty easy, and I'm going to go ahead and recalculate this one for you guys' benefit, just so you guys can see. So z-score formula I wrote right here, hopefully you guys can see that. So you're taking the first x value, which is 1, and you're subtracting it by the mean, which is 3.8, and you have to divide it by the sample standard deviation, which we just calculated. And you can even go 3.5. I didn't do 0.35, so the 0.0035, I didn't have that at the end. So my answer would be a little bit different, but it's pretty close. So it's negative 1.45. 83 is what I got, and then 5, it's 4.556 if you did round all the way to 4 digits. So that's how you calculate the first z-score. Then you have to calculate every single z-score for all of the x's and all of the y's. And I'll go ahead and do one with y for you guys too, just so you guys get the gist. So 2 subtracted by the mean, we're subtracting the mean, which was 5. And then we have to go ahead and divide it by the sample standard deviation, which I calculated out to be 3.87. and we get negative 0.7752, which is the same thing I got here. I just rounded it. Okay, so now you have to calculate all these numbers, which I did. Hopefully you guys got the same numbers. If you didn't, try to go back and understand why. Then what you want to do is multiply this row by this row. So we take the z-square of the first x and multiply it by the z-square of the first y, and you should get this number. Same thing, z-square of second x multiplied by the z-square of the second y, you should get this. Z-square of the third x multiplied by the z-square of the third y, you should get this. So on and so forth. Then, once you get all these multiplied z-squares, you add them together. And when I added them together, I got 3.0954, which hopefully you guys got. If you didn't, try to see what happened and where you went wrong and all that kind of stuff. Now we got this z-square, right? So we're very close. I mean, we got this sum of all the z-squares. And if we look back at our original formula up here, hopefully you guys can see it. I am not sure, but I hope you guys can see it. All we have to do is divide this by n minus 1. So we have 5. So n is 5. We should have write that down somewhere. I should have. So n is equal to 5. So n minus 1 is 4. So we're dividing this number that we just got by 4. So we have 3.0954 divided by 4. And we get 0.77385, which is what I got right here. Hopefully you guys see that. And so depending on how you rounded and all of that stuff, you should hopefully get about 0.77 as your R. Okay? And that's your Pearson correlation. So the answer for 18 would be 0.77, and that's equal to your R. Okay? Cool. Now we need to calculate 19, which is the R squared. Now this is also really not hard once you get the hang of it. All this stuff is really easy, as long as you get the hang of it. So if you guys don't get it, it's not a big deal. You just need to practice a little bit, and hopefully it'll come to you real soon. So just keep on practicing. I know you guys are all really smart. You can all definitely get it. You just need to practice. Okay. So the next part is the R squared, right? We calculated the R. So fast check. If you just wanted, you'll have to show your work, but if you just wanted to get it, that's how you could get it easily. It'll be a little bit off because of rounding and stuff, but you could just square the R and you'd have that. And that's a good check. That is not the way you get it, but that is a good check for it. Okay? Cool. So R squared is also super easy. All you need to do is write down the formulas. Keep writing down these formulas. So the formula for R squared is right here. I hope you guys can see it. It's this. It's just the sxy squared over sxx times syy. Whew. Okay. So all we have to do is calculate all these three things independently of each other. But the first step to do that is we need to get these columns. So x, y, which we have already been given in the problem. So I just wrote those down again. xy, which is just the multiple of that. X squared, the square of x. Y squared, the square of y. So to get this, it's super easy. 1 times 2 is 2, 4 times 1 is 4, 6 times 10 is 60, same thing. 1 times 1, or 1 squared is 1, 4 squared is 16, 6 squared is 36, so on. 2 squared is 4, 1 squared is 1, 10 squared is 100, 4 squared is 16, and so on. I did this whole chart. And then when you do this whole chart, this is probably going to only take you like, I don't know, maybe a minute, 2 minutes at the most. You should really try to get this whole problem down, if you can, to 5 to 6 minutes, calculating R squared. It's going to be a rush, but if you can practice to get it down all in under that time, that'll be a really good practice. Then you'll be really ready for the test. But don't rush it so much that you're getting the wrong answer, because otherwise there's no point. Okay, so after this, after you do this whole chart, you have to sum it at the bottom. So the sum of x is 19, sum of x, the sum of y is 25, sum of xy is 118, sum of x squared is 87, sum of y squared is 185. Now we have that. Woo. And we all got that just by summing all these up. So we add all the x's, all the y's, all the x times y's, all the x squareds, and all the y squares. Super easy so far. Okay, so now we just follow these formulas to get y squared, because that's what we need for the y squared formula. So I just did it out here for you guys, so you can look at it, but I'll also go through it real fast. So we just take the sum of x squared. Remember, like I was saying before, follow this order of operations and you should be fine. Parentheses, exponents, multiplication, division, adding, and subtracting. So the first thing we do here, we have to take the sum of the sum of all the x squared. So we already so the sum of x squared, there's no parentheses here. So that would be 87. And then the sum of all the x's, and we square that number. So the sum of all the x's is 19, since it's in parentheses, and we square that number, which would give us 361. And we divide that by 5 because we're dividing by n. So we just do 316 divided by 5 is 72.7, and we subtract it by 87, which would give us 14.8. So 14.8 is equal to SXX. And like I said, I keep track of it on the side. I don't know if you guys can see that, but I hope you can. I keep track of it on the side, just because it makes everything a whole lot easier at the end when you have to calculate all these numbers out. You don't have to rush to find anything. It's all here written for you. Same thing, you find y. So the sum of y squared, we calculated out to be 185. Sum of y, and then you square that number, that's 25 squared, which is 625. You divide that by 5, you get 125. So you take 185 and you subtract 125 and you get 60. So now you have to find SXY, which is just the sum of SX. That doesn't, that looks like an S. Okay. The sum of SX, XY, sorry. The sum of XY is equal to 118, and we subtract 19 times 25 over 5. So we subtract the sum of x times the sum of y over n. Over n. And so you should get 118 minus 475 divided by 5, which should equal 118 minus 95, which gives you 23. Okay, now all the hard parts are over. And it's not even hard, it's just a lot of work. So as long as you stay organized, you should be very good to go. So now we just need to calculate the formula for y squared again. So I did it on the side here, I put it all here, and then I did sy squared, which is 23 squared, and so that's 529. And so to put it all in the formula, you just do 529